Hi, pre-calculus. Well, I'm at home. You're at school. I'm not under quarantine quite yet, but I'm awaiting tests for a family member. So hopefully everything will turn out well. I get a negative result, and I'll see you again tomorrow. If not, I guess I will see you after fall break. That's a good 2 week time period for me. But today I have some homework questions for you. I picked out quite a few questions on the worksheets we've done 13, 14, and 15 in chapter 1. So you can follow along and correct things there. I tried to pick out a variety of questions that would help go over these new topics with functions and inverses. So get out those worksheets, follow along, correct them. Tonight you have the review 116 to do the selected questions off of. Those answers will be posted on Schoology by this afternoon. If you have other questions besides the one that I go over today, if you can email me during school hours around 2:30 or 3 o'clock, I'll be making a new video with maybe a few more of those questions to put on Schoology to help you out. There will be still a short quiz tomorrow, so it will be the basic ideas that we're going over today and some of these questions for the second time here. So email me any questions so I can get more of those videos posted and just follow along here. All right, I hope to see you tomorrow, and I'll answer questions before the quiz. If not, I will see you after fall break. Have a good one. Okay, guys, let's start with worksheet 113. I'm going to do numbers 8, 16, and 19 on this one. So number 8, functions and combining functions and everything here. We have f of x and g of x. 8 just looks a little bit different than the others. So what we have here is a combination of some different pieces. So I'm going to separate these and then combine them together. So here's my first one, f of x plus h. So number 8. F of x plus h. Let's look at that one first. We're going to take the f of x function and everything inside the parentheses gets put in for x. So remember, f of x is 3x minus 6. That really means 3. Plug everything in, then subtract 6. So whatever's inside there, the x plus h goes completely inside the parentheses, not outside. You don't put the plus h at the end of the problem. So that is f of x plus h. Next, it says minus f of x. Now, minus f of x says subtract the function, because the function is named f of x. So we would have to put 3x minus 6 here. But remember, when you subtract a function, you've got to make sure you subtract all parts. So put parentheses around that. You're going to distribute that subtraction. On the bottom, it just says over h. It's not a function, that's just a variable, like the plus h right there, same variable in the f of x plus h. So over h. That's what you should start out with, and we're going to simplify from there. Hopefully some real quick, simple arithmetic. Expand, combine like terms, and reduce. So this is 3x plus 3h minus 6 minus 3x, and here's our plus 6 from distributing over h. That ends up with, some things cancel here and just combine to be zeros, just 3h is left over h and reduce. That all ends up being 3. That big mess of a function is just 3 at the end. Next, we've got number 19. Where was it? 16. Here we go. 16. G of f of h of x. So g of f of h of x, 3 functions, one inside each other each time. We are going to pay attention to the domain issue on these. Talk through that. Now, if you had a question like on number 13, notice that f of h of x is inside here. We can talk about 13 as we go. But this one just has a couple layers to it. So the first layer is h of x. H of x is just root x. So it says put that one into the f function, and then we'll put all of that into the g function. So we can do step by step here. So the first one, f of h of x, f of root x. Remember, f of x, x squared plus 1 just really means stuff squared plus
1. And we're going to put inside there root x. So all of that simplifies to just x plus 1. X root x squared is just x. So this is all just x plus 1. Now we need to do the g function around this. So we're going to do g of x plus 1. The g function says 1 over x, which is stuff, minus 3. And inside that, we put our x plus 1. So this all ends up with 1 over x plus 1 minus 3 is minus 2. Now, what we have to do for the domain is you always look at the inside function because a lot of stuff is simplified out of this problem from what we put into it. So the h of x is what we're going to have to look at. H of x says for root x, that means x has to be greater than or equal to 0. That is the domain. So you can only square root positive numbers and 0. So that's the domain that we know from square root x. So we're going to look at the answer and see if we still know that or if we still see that in the problem. Down here in 1 over x minus 2, it looks like I just can't use a 2. That's the obvious number. 2 minus 2 would make 0 on the bottom, so I can't use that. But it doesn't look like I can't use negatives anywhere. So that's what we have to say on this function. We have to say from the inside, x must be greater than or equal to 0. And we have to keep that information in our final answer. It wouldn't have been obvious to someone that just saw 1 over x minus 2. So explain the inside-most domain if it's not obvious anymore. Okay, and number 19. 19, we've got function decomposition. This one, these are mostly quick problems because we see parentheses, and that's our inside function. We're going to do it like this. The inside function is our g of x. That's the inside here. And the outside function is our f of x. Okay, we're going to try to name both of those. So if I put g of x into f of x, we end up with this h complicated mess over here. So the problem is I don't see parentheses. Parentheses are a big giveaway that here's my inside function. And this one, the problem is I have x's in 2 different places. So when we're looking for an inside function, if you can't do it the easy way and just take the parentheses, look for the same thing being repeated in a couple of places. So on this one, I see an x squared a couple of times. I'm going to name that my g of x, x squared. So whatever I might see repeated a couple of times in the problem. That means f of x is everything happening around that. So we can kind of take this x squared out of it, and this would be something over something plus 1, and we get to hold its place in there. So the f of x is something over something plus 1. If we get x squared in there, it looks like the original. Instead of x squared, though, we have to have a variable to hold its place. So we just call that a new x. So f of x is x over x plus 1. The g of x is x squared. And that's how you can take a function apart. Worksheet 114, let's see, I have 2b, I have number 4, number 10, and number 14 is what I'll do here. So 2b, this one is function or not, and one-to-one or not. Now, the obvious thing is this is called f of x, so it is a function. You only have to worry about that if it's not solved for f of x or solved for y. So this is a function. This is a rational function that we could graph with vertical and horizontal asymptotes and things like that. But the one-to-one is the hard part. How do we tell if this is one-to-one without actually going through the whole process? I don't want to graph this whole thing. I'm going to look for clues. So with clues here, one thing I'm going to look for is any kind of squared. Now, here's the reason why on the top one here. Remember, the numerator gives us x-intercepts. So this would have an x-intercept of 0, 0. But more important, the squared means that is a bounce. Now, anytime we think of a bounce, just draw a simple bounce. Here's the x-axis. If we bounce, we go down and come back off. That does not pass the horizontal line test. So that just information there, that the x-intercept is a bounce, tells us it's not one-to-one. Denominator, squared, again. So there's our big clue. This is a vertical asymptote, and the squared means at -3, the two sides are the same on both sides, same direction. So that's another clue we could get. Here's a vertical asymptote. So the squared would mean if one side goes up, the other side goes up. I don't even really care which side is which. If they both go down, that's fine. That doesn't pass the horizontal line test. So as soon as you see that squared, we know a factor being squared is not 1 to 1. That's our big clue. All right, so number 4. Number 4, and 5 is just backwards from this one. It's a little bit simpler. So number 4 here, f of g of x. We're going to put one inside the other again. This one turns out with some complex fractions. So f, the outside, g, the inside. F says that we're going to have stuff over stuff plus 1. Remember, the x's are placeholders, and the g of x inside, g of x is 7 over x. We're going to put 7 over x in each of those. So 7 over x over 7 over x plus 1. So review our complex fractions. We don't like the denominators. Multiply by a common denominator to get rid of it. And that would just be an x for both of those. Well, 7 over x times x is just 7 on the bottom. That one cancel. We just get 7 plus, don't forget to distribute, 1 times x. 7 over 7 plus x. Then check the domain. G of x was inside. The original g of x up here cannot have a 0 in the denominator, so x cannot be 0. Take a look. Doesn't look obvious that x could not be 0. Maybe -7 is obvious. So -7 will make the denominator 0, but we have to say from the inside function, x can still not be 0. It's still not allowed in this. Basically, if you plug 0 into g, you get undefined, and you can't plug undefined into f to do the second step. So that complete thought has to be our final answer. Number 10, inverses. So a little bit of work with functions, and now we're on to inverses. So the backwards equation on these, if possible. On number 10, so remember the steps you have to go through. First step, is it 1 to 1? This one is a parabola. If we look at it first, a parabola is not 1 to 1, but we're given a domain restriction. This parabola is at -1, 4, and it would have both sides. This less than means left side. So we are only using the left side of this graph. So the left side of this is 1 to 1. It passes the horizontal line test, doesn't have both sides. So we're good. We can say this is a 1 to 1 function. So now the order was switch x and y, and then do what we need to solve for y. So this would be x equals, we'll say y plus 1 squared plus 4. All right, do your order of operations correctly. Subtract 4, y plus 1 squared. Square root to get rid of the squared, and whenever you put a square root, you've got to have a plus or minus. So that plus or minus is going to cause us problems. Subtract 1, plus or minus root x minus 4 minus 1 is y. All right, so we switched x and y, solve for y, but the problem is the plus or minus. That actually means our result is not a function. You can't have both a positive and negative answer. That wouldn't be a function. Well, you can only have one answer. So we have to choose, okay, based on what we already know. So for our inverse, we only want one of these. You can think of drawing the graph if you want to. You can look at domain and range. So this plus and minus affects the output. So we want to know the range. So that means on the original one, we want to check the domain. The domain of the original function is x is less than or equal to -1. It's what they gave us here. This left side was a domain. That means down here the range must be y is less than or equal to -1. Well, how do we get negative numbers less than -1? We have to start with a negative from the square root. So that's one way to do this. Our inverse is going to be negative square root x minus 4 minus 1. The negative is a required part of that answer. Now, the quick way that we want to recognize is just on the graph. The left side for the domain, the left side of a parabola would go with the bottom side of a square root. So this one would actually need this to be a proper reflection. That's the bottom. So left side goes with the bottom. That's the negative. So negative matches the left side. That's the quicker way. So if you remember that pattern, there is our final answer. We chose the plus or minus on there, and it is a one-to-one function at the end. So number 14, I put 13 on there because that's a parabola. It's squared. This is not one-to-one. There's no fix to it, so we can just quit. That's not possible. Okay, that's why there wasn't an answer on 13. 14, let's check. One-to-one. That's a square root, means it's a half parabola. Starts over here at -6 and goes that way. That's one-to-one, so we're good. We can switch x and y. X equals square root y plus 6. Backwards, square both sides. That gets rid of the square root. Subtract 6. X squared minus 6 equals y. It's a nice little parabola for us. X squared minus 6 equals y is not, though, a one-to-one function. I just said it was a parabola. So that's not a one-to-one function. We need to fix that. There's no plus or minus to check. This one is, if it's not one-to-one, restrict the domain. It's kind of like the last problem. We have to do it backwards. What can we do to cut this in half? So we need to know where the vertex is. The vertex of this is at 0, -6. The 0 is the important part. We need to choose if I want greater than or equal to the 0 from the vertex, the right side, or less than or equal to the 0, the left side. Which one do we want? Because we can't keep both of these. We have that -6 here. We would have both sides. So which one are we going to keep? On the original graph, we could graph both of these, and what we'll see is the reflection we need is the right side. That would make a nice little reflection over that line for us. So we want this. We can do the positive square root is what we had at the beginning. That means we need the right side, and that's a domain and range switch. The range of the original graph was greater than 0, so the domain needs to be greater than 0. Our complete answer for f inverse of x is x squared minus 6, but because that's not one-to-one, we get the domain restriction that x is greater than or equal to 0. There is the full answer that we need. 115. 115, I've got 4, 5, 10, 11, and 19. So 4 and 5 get a little bit trickier into some of these complex fractions with the function composition. So h of f of x, we can set this up hopefully a little bit quicker here. H is 2 times stuff squared over stuff plus 1. The f of x that goes inside there is 1 over x minus 1. Now I'm going to think about this one a little ahead of time. F of x, look at the 1 over x minus 1. X cannot be 1. Let's check that at the end. Make sure it's obvious to us, or we need to say it, that x cannot be 1. Okay, I'm going to simplify this a little bit before we do the complex fractions. So squaring this fraction, square the top and square the bottom, means the bottom is just x minus 1 squared. I do not want to FOIL that out. The top is just 1. Multiply by 2, we get 2. Remember that 2 only multiplies the top. The denominator is just 1 over x minus 1 plus 1. So complex fractions, multiply by something. To get rid of x minus 1 squared, we need an x minus 1 squared on top and bottom. X minus 1 squared will take care of a single x minus 1. So that is our common denominator. Cancel in the numerator, and this equals just 2 over. In the denominator, one of these cancels, so we have an x minus 1 left in the first term, plus 1 times that, we have an x minus 1 squared in the second term. So we got both of those there. So we got rid of the complex fractions, multiply it all out. This is 2 over x minus 1 plus, that's x squared minus 2x plus 1. Combine those, you have 2 over x squared minus x, and that is 2 over x times x minus 1. And take a look. That x minus 1 means it's obvious to us, it should be obvious, that we can't use a 1. It makes the denominator 0. So because it's still in the denominator for us to look at, we don't need to list that as an extra domain restriction. So that is our combination, that composition function. If we do these backwards, j, or not these two, j of f of x, just different ones, together, j says x plus 2 over x, so stuff plus 2 over stuff. And the f function inside says 1 over x minus 1. 1 over x minus 1. Complex fraction again, and we know x cannot be 1 at the end. We'll make sure of that. All right. This one, multiply by, we don't really need the parentheses. We just need an x minus 1 out of the way. So cancel, and we get 1 plus 2 times x minus 1. Make sure you distribute it to both parts. On the bottom, just cancel, and it's over 1. We don't have a fraction anymore. That's good news. So we just have 1 plus, this is 2x minus 2 if we distribute that, and that is 2x minus 1. Now on this one, there's no more denominator. It's not obvious there should be any restriction, so we have to include what we said at the beginning. We can't use a 1. That wouldn't go through the process correctly. So the domain of the inside function still has to be listed. All right, numbers 10 and 11, give the inverse if possible. 11 is a little bit quicker on this one. I'm going to do that one first. Similar to what we did, it's a square root. So is this 1 to 1? It is. We should know square roots are. This one just goes to the left. It goes like that. So that's our square root. It's the top part of the parabola, a positive square root. Think about that for later. X equals root 4 minus y square, both sides. Make sure you watch out for this minus y here. If you subtract 4, you have negative y. So y is equal to negative x squared plus 4, divided by that negative 1. This, we have to think, is 1 to 1. No, it's a parabola. So fix our vertex is at 0 comma negative, or 0 comma 4. So it's either going to be a greater than 0 or less than or equal to 0. Choose one of those. Make sure you get the x value of that vertex. So on this one, it's the original problem went to the left, but that really doesn't matter. This parabola goes down, okay? So we've already kind of fixed that side. We have to know what side of this we want. And remember, positive is the top part. That would mean we want to go with the right side, and that's the greater than 0. So F inverse is negative x squared plus 4 with the restriction that x is greater than or equal to 0. Right side goes with the top, top goes with the right side. So this one, this would be the graph of that, if we want to check there. Check domain and range. The range of our original is greater than 0, so this domain has to be greater than 0. All right, 10 takes a little bit longer. It's a new type of function, but this one, is it 1 to 1? This is kind of what we talked about with 1 to 1 at the beginning a couple of problems ago. There's nothing in here squared, so there's no bounce, there's no side by side. We're going to get a graph that kind of looks like this with the vertical asymptotes. Two separate parts of the hyperbola shape in separate quadrants. So this one we can say that yes, it is 1 to 1. You don't have to make a big graph out of that. Look for the squared clue. So this one would say x equals y over 2y minus 8. So how do we get the y alone if it's in both parts here? So first step, this is going to come back to us several times this year. First time we'll see it here. First, we don't like the fraction, so multiply. Okay, you can put x over 1 and cross multiply if you want, but this is just y equals 2y minus 8 times x. So that's 2xy minus 8x. Okay. Now, get the y's on one side. Okay, we don't have fractions anymore, that's good, but we have two terms with a y in it. So move them to the same side. Y minus 2xy equals, careful that 8x has a negative in front of it. So gather the y's to their own side, the one we're trying to solve for. And this is where we get the important step. Why did we gather them? Because now what we can do is we can factor. Factor out a y, that's a GCF. Just the y part, even if there's more. That would leave us 1 minus 2x. We took the y's from each one out, equals negative 8x. And that allows us to divide. We're going to gather all the y's on one side so we can factor out the y, and then you divide by the parentheses, 1 minus 2x. So you end up with y equals negative 8x over 1 minus 2x. That is an acceptable answer. In the book, it does the opposite. If you divide a negative 1 out of everything, it is 8x over 2x minus 1. That might be even better without the negatives. Those are the same thing. That is a one-to-one function again because there's no factors that are squared. So this process here, get the y's on one side, factor out the y, and divide. It's going to be helpful for us in many problems as we go through this chapter. Last one, let's do a graph here. Get this graph sketched as the inverse. It says first domain and range. Remember, for domain and range on a function like this, skip over the asymptotes. The domain is negative infinity up to 2. That's our first place we skip going across. And from 2 up to infinity. And then the range, negative infinity up to 0. We skip over the horizontal, and then 0 up to infinity. Now, part B, graph. I'm going to make a little chart here. Original and the inverse. The original function we know has things like a vertical asymptote at x equals 2, a horizontal asymptote at y equals 0. Remember, every x and y thing switches. So we're going to have y equals 2 on the inverse, which now makes that horizontal. And the vertical is x equals 0. Switch the x and y on each of those. So I'm going to put those in here. X equals 0 and y equals 2. Okay. So this is going to turn out to be the same kind of rational picture that we have, this hyperbola, just in a different place. Now I'll just try to move these up a little bit. Let's try to get some points. Now you have to estimate. So estimate. On a quiz, we will give you clear points to use. Okay, this one we do have to estimate. The y-intercept looks like it's about 0, negative 1/2. So I'm now going to have negative 1/2, 0. An x-intercept, let's put that on here. That kind of tells us the quadrant we're going to be in the red one, that it's going to be in this area. That's really all we're looking for in this these rational graphs. Another point I could use, I'm just going to find one that's about right there at 3, 1. Now I'm going to have 1, 3. So I chose one on the other side. 1, 3 gets me up here in the top right quadrant. So getting a couple of those points in the right quadrant. And then make the shape look good. You have the asymptotes to follow. So use that idea. And you want to check, does that look like a reflection over that diagonal line? Here's that diagonal line going through there. I'd say that looks pretty good. So it looks the same on both sides of that y equals x reflection line. That's what we can do. So any of these horizontal or vertical asymptotes, as well as points, all will reflect, change the x and the y. Last thing we've really already answered, because that is part C, give the domain and range of the inverse. Remember, all x and y switch. So for part C, we're going to go back up here and just switch these. The domain is now negative infinity to 0 and 0 to infinity, and the range is now 0, negative infinity to 2 and 2 to infinity. Okay? Just switch those around right away. All right, hopefully that helps with that sketch. All right, other questions, please email me. I'll try to get some of those. If you email me before the end of the school day, I will be checking. All right. So quiz tomorrow on the basics of these inverses and everything.